Ladies and gentlemen, my name is Natalya Keberle and I will present the result of our study we carried out at the Department of Computer Science, Zaporizhia National University. In the presentation, I'll outline the troubles that appear in scientific search for publications. Then I'll voice the main idea of the solution that can handle the low specific information need with criterion of stopping the search. The criterion allows reducing the size of search results and at the same time keep them complete. After the general overview, I'll dive deeper in the details describing the workflow, assumptions and the terminological saturation as criterion of stopping the search. In the last section, I'll show the results of experiments and discuss them. The studies in information retrieval show that, in most of cases, scientists searching their publications aim either write good related work section or study the new trends or new area they are unfamiliar with, or support the awareness in the area of their expertise, or look for other people that are experts in some scientific branch. The listed goals affect the information need, turning it into a low specific one. That means the person doing the search does not know exactly if the search point is reached. For instance, if you are not expert, you cannot be sure that found publications present full landscape of your area of interest. So the main research question is, let's find a calculable criterion of stopping the search. It should be formal, easy to calculate, providing necessary evidence. Earlier, the other researchers proposed solutions, but all of them were informal or requiring expert cross-check. The solution proposed make use of algorithms of automated term extraction from texts and evaluation of terminological saturation. The great benefit of the solution is a broad minimal number of the publication that should be analyzed. Keeping in mind that reading one publication can take several days, the less text we must read, the more time we save. The counterpart requirement is the completeness of the publication set, so we need to balance. The algorithm of controlled snowball with saturation criterion is shown here. The red brackets highlight the addition to the initial controlled snowball algorithm application of terminological saturation criterion. If the terminological saturation is reached, user gets a relatively small list of publications. If the saturation cannot be reached, this means several things. The research domain is developing, and there is no stable terminology yet established. We do not gather all terms in the domain. Instead, we detect that there are no new terms in Snowball subsequent iterations. Controlled Snowball was presented by the authors earlier. Its main idea is collecting the referenced and referencing papers based at semantic similarity measure. Such a measure should be supplied with citation analysis to get seminal publications. We have made some modeling assumptions shown in the slide. First assumption related to information need. The selected publications have desired subject and are important. List of selected publications is short. Selected publications contain all terms of desired subject area. We know that information need is partially represented with a set of publications. We also assume that user is not the expert, but she knows some keywords from the subject area. We assume that publications can be split into a hierarchy of sentences and words, and publication references allow building the citation network, directed almost as cyclic graph. Presence of all important terms means for us terminological saturation, and full text of publications may be not available. So what is the terminological saturation, our stopping criterion? Terminological saturation is a situation in gathering publications when adding new publications does not essentially affect the ordered list of terms used to describe a domain of interest. We seek for a minimal publication set which is simultaneously terminologically saturated. For the experiments, we selected a topic ontologies because it is present in all major scientific databases. We would like to find all the seminal publications in the topic. The experiments were conducted to check the following objectives. Does terminological saturation exist for the topic? And what is the size of publication set that we will be enough to read to get acquainted with the topic ontologies? We obtained 4 ordered document set. Microsoft Academic with our controlled Snowball, Microsoft Academic with automatically assigned category ontology to a publication, ACM Digital Library with label ontology assigned by the publication authors, and Google Scholar with keyword search for word ontology. Each set contains about 220 full publication sets collected in semi-automatic way from different sources. The results show that the terminological saturation is reached faster for the publication set gathered with controlled Snowball over Microsoft Academic than for all the others publication sets. Also, we see that the terminological saturation is reached in general for Microsoft Academic searches and Google Scholar, but is not reached for ACM Digital Library. Here we can see that in the numbers, controlled Snowball over Microsoft Academic proposes the set of 160 publications, whereas for all the other searches the sets are larger. So now let's discuss the advantages of the controlled Snowball with stopping criterion. First, it is good to have a formal calculable criterion of stopping search. Second, for some lists of publications, such criterion is fulfilled, meaning that the terminological saturation exists for those lists. Third, Microsoft Academic Search plus controlled Snowball produce the minimal publication set fulfilling the terminological saturation criterion. The weakness of the proposed algorithm is that for different domains, the saturation behavior will differ. Our further research includes the rerunning of the experiments for other domains and using expert knowledge to assess the recall and precision of the extracted term sets, and application of the proposed algorithm and stopping criteria to other known citation networks to evaluate the recall and precision of our controlled Snowball.